Hello mariners, hope you guys are doing well. In this video we are going to talk about autopilot. Well, please take your pen paper ready because after watching this video I am definitely sure that you no need to read the book once again. So please make a notes, and also if not, this video is available for you at all time. You can have a view again and again. What is autopilot? So autopilot is basically we used when we are doing a particular course for a long time without any alteration. So because because any deviation from the set course is controlled. If there is any deviation, it is controlled by the electronic and automatic through the help of this autopilot system. By using this system, we not only relieve our helmsman from doing the steering duties, but also we involve that person while keeping an extra lookout to reduce the manpower. Basically, we are reducing a manpower on the bridge. So there are lots of things which means there are lots of controls which are used in this autopilot to maintain a set course through that particular time or particular voyage for till that one leg to other leg. Corrective action in this autopilot is taken by the lots of equipment things are installed in it with the help of our hands, bring to the ship back to the set course. While using this autopilot, it only does not relieve the helmsman from doing steering duties, but also it increases the average speed of a ship, because we are doing a ship set course and we are not doing a zigzag motion. Then definitely on doing a straight line course, the speed will automatically increase because we are not moving our steering rudder. If rudders are moved, the water pressure acts on it and also the ship speed will reduce. But this autopilot systems also increases the ship speed. Now let's have a look at how this autopilot system works by a simplified block diagram. Well, mariners, this block diagram I have taken from the Modern Electronic Navigation aids book that is written by the Bhatia and Sinha sir. With the help of this I will explain you the working principle. So any course we need to do, we give a order to our rudder. This order is given with the help of a course set control that is known as a knob. That is on the bridge, it has a knob. And any course is given to that, and we will observe, we will use to see out from the compass that what course we are giving. As per compass we set that course. This signal both goes to a comparator, and after that it goes to a integrator and differential. This is one of the part which I will discuss further, that is a PID control. Basically it is known as, in a simple word. So through this it just sets a course that while deflection, if we are deflecting a such amount from that compass and from the course, that a new course which we said and the previous course what we are doing, if there is any deviation, so due to this, basically this terminology I will discuss further. And after it sets a desired course which we are going to now we are going to steer. After it goes to a summing amplifier, it just amplifies that signal, and further it goes to a error amplifier, and if there is any error, it will just calculate that particular error and it will just remove that error, and further it goes to a telemotor transmitter, where telemotor transmitters collected all the signal what it is coming, and it says to a telemotor receiver, and telemotor receiver will receive the signal and it goes to a steering gear, and after steering gear, this is a control unit, and from this our steering gear will operate, that is our rudder will operate. And here it is a feedback is given to that. Feedback is coming from this area and it shows to our rudder angle indicator that is on the bridge. From there we see that if there is whatever the set course we are going to do is that course is correct, showing correct or not, means our rudder is doing the same course or not which we have given, that is shown by the rudder indicator. If there is any error, again we will show it our course from the compass. This both will have a same thing almost, that whether rudder indicator is showing by 5 degree, 10 degree or whatever the set we are doing. So as per that we will do it, and if there is any error, it will send to that error amplifier, and again the entire process will take place, and hence this autopilot system works. So well, mariners, as you have seen that how the block diagram means how the autopilot system works. So now let's have a detailed view on its control unit, that how it's, that is PID control works. So well guys, let's begin with the detail of a control unit. So this is a proportional controls. How does it work? I will show you that if due to any cause, or if we are giving a certain course to steer to the ship, the rudder will deflect from its course. We are doing a course of like 0, 9, 0, and if due to any cause it's deflected from the set course, and it's deflecting from the set course, like it's moving towards that 0450. So what the proportional control will do, it will just give an entire opposite control to the rudder, opposite deflection to a rudder, and the rudder will just move at the same amount whatever our ship has been deflected from the set course, and it will keep on going. After crossing our set course, again it will observe that we are again deflected from our set course, and again it will give on rudder as whatever amount we have moved from our set course, and it will continue on doing a zigzag course. So this is a proportional control, how the ship's autopilot system try to keep the vessel on the set course. Well, this is our derivative control. So well, I am going to explain that how does it work. So we are doing a course of 0, 9, 0 degree, and due to wind, sea, current, or due to any cause, our ship has deflected from the set course. Okay, so now the ship has been deflected. So after seeing this, our autopilot will give a command. It will simply give a command to do a course of 090. So now rudder will give a signal will give to a command to a rudder, and rudder will deflect. Rudder will move in such a way that our ship will start doing 090, that is almost parallel to our previous course, set course, that we are doing still a 090, but with a from a different position. So well, mariners, I had showed you the proportional control and the derivative control. Now let's talk about the that is our integral control. So integral control does not work on the sensor. It means it's also work on the sensor. This is a control that comes under work as per the control of our ship, means like due to our ship structure, that is like we are doing a certain heading, and due to the some structure of our ship, it's not able to maintain a such head. So this integral control comes into effect by sensing such error, whatever the error which has come into the ship while the time of this while the construction of the ship, and such other the things, where the data signal are produced by continuously sensing the heading error over a period of time. Applying an appropriate degree of a parameter help is used for the purpose. So well, these are the normal view. Separate we have seen that what is integral, what is the derivatives, and what is proportional. Now let's have a combined view of a PID control, that how this, when we combine all these different things, then how this works, means how the autopilot finally works. Well, I think that while looking on the figure only, it is clear to you guys that how this PID control works. It simply works that as per the proportional angle, as per the proportional properties of the autopilot system. When the ship has deviated from the course, it will give a course error and it will start deflecting from that area. And as per the proportional, we have to do a same zigzag motion, but due to a derivative controls, what it is doing, it's trying to make the vessel to the parallel of this course, okay, parallel to the previous course, but still the vessel is away from the set course. So again, as per the proportional control, it gives again the command to a rudder, and against the rudder is working, and as soon as due to the proportional and derivatives control and due to the error on the ship structure as per the integral control, it will start doing the course to steer. Hope guys this thing is clear to you, and it's really important question in written and also for the oral point of view they used to ask these questions. Well guys, I hope it's the things which we had discussed is clear to you guys. So well, now let's have a view on the control on the panel. What are the controls that are on the autopilot panel and how do we use and why they are given? So well, the first is a course selector knob. So from the name only it is clear to you that what does it is mean by a course selector knob. So course selector knob is used to give a command to the rudder to set a course. Now a rudder control. So this controls determines the amount of a rudder to be used to correct the slightest amount of a deviation of the equipment that is due to external causes. Now a counter rudder. So what is a counter rudder? So this control determines the amount of a counter action by the rudder to use to steady the ship at a certain course that we are doing due to wind and sea and other causes when the vessel are deviating from the set course. So this is a we give a command, we have a knob and we set it to 5 degree or 10 degree. Whenever we are deviating from the course, the rudder will deflect by 5 degree or 10 degree to maintain our course. So yaw, what is yaw? So the setting of a yaw controls depends upon the wind and the weather condition and their effect on the course keeping ability of the ship. In bad weather with a strong wind and rough sea, the higher value should be selected, while in calm weather a low value is a. So yaw is there is a knob on our autopilot panel, and it is used when we are in an open sea and we are not doing hand steering. So due to a current, sea or anything which by that of point which we are going to deviate from the course, so in this we give a command that if my vessel is deviating from the wind or the current or anything, it will give us such amount of a command to my rudder, and I will able to maintain my set course. Now the other thing is given is a parameter help. So this control is used when the ship is being driven off course by a crosswind rudder angle. You should be adjust sufficient of the set to this drift. Now rudder limit. So what is the rudder limit? So maximum rudder limit to be used at all time. So the maximum limit of a rudder to be used when correcting the ship head or when altering course on autopilot itself. So from the name only it is clear that rudder limit that we had deviated. So we have set a limit to our rudder that rudder should not move more than 5 degree or 10 degree in any condition to maintain our course. Like we are doing 090 and our vessel has deviated, means our vessel has deviated due to any cause and it's trying to doing a course of 080. At that time what we simply do is that we give a command to a rudder, and in a rudder limit what we had applied to a rudder that while maintaining our set course the rudder should not move more than 10 degree or 5 degree, whatever the limit we have set. The next is off course alarm. So this is one of the very important feature of our autopilot, that whenever this our autopilot system does not operate it or not able to keep a set course, and when we have deviated from our set course by 5 degree, whatever the OW or the master decide to keep, so whenever we have deviated from the set course by such an amount, So this pen, this off course alarm will give an alarm indicating that we have deviated from the course, and the OOW will take the action. Either he will do a hand steering, or he may just simply can with the course selector knob he can select the desired course. So well, synchronization control. So this control temporarily disconnects the gyro repeater from the main gyro so that the heading of a repeater can be synchronized with the master gyro. This is usually not required to be done except when the gyro is switched off and restarted, or for an exceptional reason the repeater has drifted off. Now, auto, follow up and non follow up. So this is the things that what does it mean. So auto means we have put the knob to auto, means after doing auto the vessel will automatically maintain its course. Okay, so these switches allow a navigator to choose between an automatic steering or a manual steering, and in case of a manual steering failure, non follow up system of steering may also be chosen. So auto, you had understood that what does mean by auto steering. Follow up means is a steering mode. We put on a follow up, the knob is just turned to a follow up mode, and the helmsman, now the command is in the helmsman. Whatever the helmsman will do a steering, the rudder will move accordingly to him. There is no rudder limit, nothing will apply. It will simply as per the helmsman and the commanding officer. And non follow up means the entire system is failed, the auto system is not working, the steering gear the steering system is not working, then we use a non follow up. In non follow up we rotate the knob and the rudder will start moving to that direction. It will not stop and it will continue moving until and unless we not put the knob to a different direction. So well guys, these are the things. I hope it is clear to you. And also one things are on the that is known as a dimmer. Dimmer is just used to brighten up this panel area brighter, or to reduce the light as per the condition. Like when it is night we used to dim it, reduce the light, and daytime we used to brighten it. Like because nowadays everything has come into a digital form. That's gyro compass are also, that's repeaters which are on the panel, it is in a digital form to have a view on that what it is. So we use a dimmer mode. Well, there is another things on which we used for a yaw movement, that is known as a Kalman filter. So in open sea the ship is subjected to a wind and the weather, okay, so which causes the ship to yaw. So generally in calm sea this result in a small deviation of the course, whereas in rough sea larger deviation of course are experienced. For small deviation, repeaters used of a rudder is not recommended and make the steering system ineffective. In addition to overload the system, in conventional autopilot the linear filter and a weather adjustment are provided to prevent such occurrence. So this system, though based on the principle of a backless dual gain and deadband etc, have not allowed been sufficient. So in adaptive autopilot a Kalman filter is used by which the true and a correct weather adjustment are seen. So well guys, this is a block diagram of a Kalman filter. How does it work as per the yawing feature? So let's have a thing. Whatever the rudder angle is doing and the external disturbance, means due to the wind, heavy wind, bad weather, this thing is calculated and is given to a hull. After it goes to a comparison correction, it will compare due to the model of the ship whatever the rudder angle is given, and it also its signal is goes to a comparison unit, and the external disturbance setting whatever we had put from the panel, that is our rudder control, rudder limit, of course alarm, that everything is calculated. It goes to a comparison unit and it start the comparison that whatever what we are doing, what we want to do, and what the current is doing, means what it is pushing, and entire thing is compared and the correction is applied, and it comes to a filter output and it gives a output, and it's again goes to a rudder and it gives the command to a rudder, and after calculating this all things, the rudder will act accordingly to maintain a steer course what we want to steer. Hope guys this video is much useful to you and you will like it. So if you really like the video, give a thumbs up and do subscribe my channel. Thank you and Jai Hind.